Good morning, afternoon, or evening. How you all doing today? Welcome back to Mr. Morrow's Honors Geometry class. All right, my friends, today we are going to continue with 1.5. We have already analyzed and learned about bisectors. Today we're going to talk about trisectors, and then we're going to learn about how bisectors and trisectors apply to angles. So it should be a pretty good day. Now, a segment trisector, surprise, surprise. I know this is not going to be too out there for you. A trisector, think of a tricycle, a tripod. We're talking about three different objects. A segment trisector basically is made up of 2 points, 2 segments, 2 lines, or 2 rays that divide a segment into thirds, or 3 congruent segments. Again, not much of a reach. It's a trisector. And just like the bisection point, the trisection points really should be points, not point, are the points where the segment trisectors are located. Okay? This is where the segment trisectors are located. So these guys here are endpoints. But the trisection points are these 2 points. Because these 2 points, my friends, split or divide this segment into 3 equal segments. Yes, sir. Okay? So the trisection points are 2 points that actually illustrate where the segment has been trisected into 3 equal parts. Does that make sense? Okay, I'll take that as a yes. Now, let me give you an example. If AR is congruent to RS, so that means AR is congruent to RS and congruent to SC, what conclusions can be made? So if I tell you this fact, what do we know about R and S? Yes, sir, my brother. I'm sorry, whoa. What did you say about? No, that's wrong. Okay, but don't worry about it. He said that R and S trisect segment AS and RC. Wrong. A trisector cuts 1 segment into 3. So what do we know about R and S specifically? Thank you. R and S, guys, are trisection points. They're the trisection points of AC. Okay? Of AC. Now, my brother, you could say this if you really want to start getting analytical here. If you look at segment AS, R then is the midpoint, and it bisects AS. You feel me? But that's not what we were given. We were just told, what do we know about R and S in this segment AC? Yes, sir. We're going to look over proofs in a second. Bear with me. Let's learn how to walk before we run. Thank you, sir, for caring. What else can we say? What else can we say about AC and RS, do you think? AC is blanked by R and S. Thank you. AC is trisected by R and S. Good job. Thank you for trying, man. Great job. Good. Okay? So when a point bisects a segment, that means it cuts it into 2 equal parts. When 2 points trisect a segment, that means that it divides it into 3 congruent parts. Let's look at another example, if we may. Example 4 here. If E and F are trisection points, E and F are trisection points of DG, of this whole segment, DG, Okay? What conclusions can be made? Sir. Okay. And what else? Trisects DG. What? But not just because trisecting DG is kind of inaccurate. and HF or FH. Wrong one. That was the second one. Sorry. They do trisect DG. Yes. And then since it's trisected, please, please, please understand that DE now is congruent to EF now, which is congruent to FG now. That's what trisecting means. Yes, sir. Can I say angle EHF? What about that? How does this angle trisect it? This is an angle. No, I'm very happy that you're thinking, and I'm proud of you. But think about it logically. I'm not being sarcastic. How would that angle even remotely close to do anything to that segment? No. However, segment HE and segment HF, yeah, they trisect DG. And the trisection points are E and F. So therefore, DE is congruent to EF, which is congruent to FG. Yes, sir. No, you cannot say that angle EHF bisects. Because this angle, guys, does not do anything to this segment. But I'm glad you're asking, where is this confusion coming from? This is the angle up here, guys. Now, if I told you that this angle is congruent to this angle and it's congruent to that angle, oh, okay, then I could say now that EH and FH trisect angle DHG. But that angle has nothing to do with the segment. That's two of you that have asked that, so it's clearly something that's confusing. Does that help? You promise, guys? I really appreciate the honesty. It's awesome, awesome. Anything else on this, or may I continue? It's up to you guys. Continue? Okay, thank you, gentlemen. All right, guys. So let's go. Just like segments, guys, angles can be both bisected and trisected by rays, lines, or segments. Notice, points no longer can bisect or trisect an angle, right? Points can only bisect or trisect segments, okay? So what is an angle bisector? Well, an angle bisector is a ray that divides an angle into two. A ray, a segment, or a line, to be exact, that divides an angle into two smaller congruent angles. Does that make sense? Yeah? Okay. Awesome. So, for example, here, I can say that ray, how would I read this ray here? Thank you, guys. You're awesome. Ray BD bisects angle ABC. How do you know, Moro? Well, I have one little loop here, one little loop here. So that means they're both congruent. Does that make sense? Okay. All right. This guy over here, okay, we have cut it into three. Yes, sir. The symbol for bisection? No, sir. The only thing that you're going to know, see how there's one kind of quarter circle there and just one quarter circle there? That tells you that they're equal. If I had two here, then I'd have to have two here. That means they're equal. If I have three here and I had three here, that means they're equal. No, just write the word bisects. There's not a symbol for everything. Thank you, sir. Yes, sir. It doesn't matter if one's higher than the other. It matters the number of little circles. So, and they're not really circles. Let's call them arcs. Let's say, for example, I just had this one here, my man, and then I had two here. I don't care what it looks like. If this is given to me, BD does not bisect that angle. Those are two different angles then, okay? Thank you so much, guys. Now, and the one here that I circled in blue, I could show you this as a trisector, but I'm not going to yet. I'm going to show you how we can have multiple bisections, okay? Ray OP bisects what angle? NOQ, awesome. And ray OQ bisects which angle, y'all? Oh, yeah, POR. And then taking it further, though, if I wanted to take it further, I'll do it in red. I can now say also OP and ray OQ trisect angle NOR. That's what I'm talking about. That's the genius right there. Awesome. That makes sense, gentlemen. Awesome. Awesome. Well, I kind of already ruined the angle trisector part, right? Because I already did it. But basically, that's what's happening here in an angle trisector. Kind of similar to a trisector of a segment. But an angle trisector are two raised segments or lines that divide an angle into three smaller congruent angles. So in this case, ray CB and ray BD trisect angle ABE. Awesome. Thank you, sir. Okay. Very good. Yes, there's only one answer for trisector because there's, yeah. I could have had two angle bisectors here. Very good job, son. But if I'm looking for trisector, that's it. BC and BD trisect angle ABE. Does that make sense? Okay. If I had it in a triangle mode like this, and I said to you, this guy is congruent to this guy is congruent to this guy, I can now say segment VS and segment XS, or I could have reversed it, SV and SX, trisect angle. What angle does it trisect, my brothers? TSY. Absolutely. Awesome. Awesome. And literally, that's the lesson. So now what I'm going to do is we're going to go over a few sample problems, and hopefully that will help you out later on tonight when you guys are working on your homework, okay? Remember that tomorrow we have a quiz, 1-1 to 1-4. So please prepare for that. Thank you. May I continue, gentlemen? Thank you, sir. All right, guys. Whoa. What did I do here? Oh, okay. Sorry. Wrong page. All right, here we go. Sorry about that. All right, guys. Number one, is S the midpoint of RT? Really? Really? Now, absolutely not. First of all, do I even have a segment RT here, guys? No, I do not have a segment RT. All I know is that RS is congruent to ST. But in order for me to actually have a midpoint, gentlemen, Okay, I need a segment there. Does that make sense? That's a little trick, the little tricks of geometry. In order for in order for a point to be between 2 points, or in our case, in order for a point to bisect a segment, the points must be collinear. Sir. And it's not collinear. Yes, sir. I, well, we weren't even talking about the angle. He said a point can't bisect an angle. You're right, but we never mentioned an angle here. You guys got to start learning how to read what they're asking, okay? And this is good. This is why we go to school. If you knew everything, life would be boring. But no, S does not bisect RT at all. However, if it was like this, gentlemen, then could I say that S bisects RT? Then could I say that S is the midpoint of RT? Yes. Does that make sense here, guys, the difference? Awesome. You guys rule. Okay. Number 2. If B and C trisect AD, do EB, ray EB, and EC trisect AED? Okay, you said no. Why? Okay, no, not necessarily because I don't have the symbols there. I'm proud of you. You're looking for clues, and there are no clues that I said this is congruent to that, congruent to that. However, it's all about reading the problem. Point B and C trisect AD. So all I can prove right now, gentlemen, is that AB is congruent to BC, which is congruent to CD. But can points ever define the trisection or bisection of an angle? No. Can you just assume now that just because the segment has been trisected, can you just assume that the angles are trisected? The answer is no. You cannot assume that. All we can guarantee from here, from the facts that we were given, is that AB is congruent to BC, which is congruent to CD. Okay? But the fact that the segment has been trisected does not mean that the angle is trisected. Yes, sir? So the answer here is no. Go ahead, son. It would be no. No. Remember, it's a question. Do ray EB and EC trisect AED? No. Thank you, sir. Yes, sir. Well, if I know that these guys were trisected, okay, BC trisected AD, that does not necessarily mean that the angles were trisected. There's no proof of that. All I can prove from the fact that B and C trisect segment AD is that AB is congruent to BC, which is congruent to CD. That's all I can prove, my brother. You can, yes, you can. You have no proof that AED has been trisected. Show me just one piece of evidence that you can prove that it's a yes. No, it's either yes or no, my man. There's no in-betweens in geometry. There's no, well, kind of, sort of, maybe if the moon and the planets are aligned. No. It's either yes or no. And I'm not trying to be sarcastic, I promise you. It's just that's geometry. All I can prove from here, for sure, is that AB is congruent to BC, which is congruent to CD. That has no bearing, no effect, no proof at all that ray BE and ray CE trisect angle E. Yes, sir. Yes. If I had drawn this, given you those facts, but then told you this, boom, 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 then the answer would be yes. because the drawing shows you that that angle was trisected. Very good, son. Does that make sense, boys? I appreciate this. This is awesome. Continue? Okay. Let's get to a little proof. Okay. Given PS bisects angle RPO. So immediately, I like to label. So I know this guy, RPS, is congruent to SPO because it was bisected. So let's do it. Ray PS bisects angle RPO. That's given. How can I prove now that RPS is congruent to OPS? I already did it by drawing on my given sketch here. RPS is congruent to OPS because of, if not given, if a ray bisects an angle, then it divides an angle into two congruent angles. Or, again, I'm pretty flexible here, definition of angle bisector. Keep it simple. Keep it factual. Keep it provable. But keep it simple. Does that make sense, my brothers? You promise? Okay. Awesome. I see you guys writing, so don't worry. I'll give you a couple seconds. You guys are doing great. Remember, if you ever fall behind, that's why I have the videos. All right, let's check out number 4 here. And I'll leave it here so you guys can keep writing if you have to. It says here that EH is divided by F and G into the ratio of 5 to 3 to 2. So they didn't say that it's trisected, so you know they're not all equal. It divided it by F and G into the ratio of 5 to 3 to 2 from left to right. If EH, the whole entire thing, is 30, find FG and name the midpoint of EH. All right, let's check this out. The ratio of the 3 different sections here are 5 to 3 to 2. But we don't know the size of either of the segments, correct? So EH is 5x of the size. FG is 3x of the size. And GH is 2x of the size. If I take 5x plus 3x plus 2x, and I set it equal to 30, my friends, I have 10x equals 30. So that means that x equals 3, making EF 15, making FG 9, and making GH 6, making FH 15, making F the midpoint. Did you see the progression? Because if not, that's what I'm here for. Sir, thank you. Absolutely, there could be questions like all of this on the quiz and the test, all of them. That's why I'm asking, if you have a question, please ask. Does that make sense, gentlemen? Sir. No, when I quiz this section, you'll have 1-5. The quiz from 1-1 to 1-4, I would never be unfair to you like that, okay? Does that make sense? All right, we have a little bit more time, okay? I know I didn't include this in your PDF, and I apologize for that, okay? But let's just look at one more. It says here, given that KO bisects JKM. They say JKM is 41 degrees and 37 minutes. They want to find OKM in both degrees and then in degrees, minutes, and seconds. It's a little bit of, combination here. It's a little blast from the past. So the whole entire angle, my friends, is 41 degrees and 37 minutes, correct? If I know that KO bisects JKM, what do I know about these angles? They were divided into two equal parts. So when I divide that by 2, what am I going to get, gentlemen? Don't stress about this, guys. What's 37 divided by 2? 18 and a half minutes. What's 41 divided by 2? 20 and a half degrees, okay? So that's part A. That's actually, no, that's not part A. That is what the whole angle is. How do I put this all into degrees now? What do I do to go from minutes to degrees, guys? You remember? Divide the minutes by 60. Very good, okay? Now for time's sake, I'm going to cheat, and I'm going to use a calculator. So I've got 18.5 divided by 60, and that will give me basically 31. Yeah, so this is 20.5 degrees plus 0.31 degrees, so that'd be 20.81 degrees. If I wanted to go that route. That make sense? Because the 0.5 I can add to the 0.31. See what I'm saying, brother? I saw your face was like, what did he just do there? Does that make sense? Awesome. Now, what if I wanted to do this in degrees, minutes, and seconds? All right. So I've got 20.5 degrees, and I've got 18.5 minutes. Okay. What I would do here is I would take that half a degree, and I'd add it to minutes. So I have pure 20 degrees now. This half a degree is 30 minutes. So this would become 48.5 minutes. Then I divide this bad boy by 60. So 48.5, yes, I am cheating, divided by 60 would be 0.80833. So what would happen here is this would be 20 degrees. Whoa. Actually, no, wait. I'm going back to degrees again. My bad. 20 degrees. This half of a minute is 30 seconds. So this is 20 degrees, 48 minutes, and 30 seconds. Does that make sense, boys? You sure, my man? Promise? Thank you, guys. You guys rule. Now, let's see if I could do one more right quick. Yeah, that's it. That's the last one. Okay. I say that line CM bisects segment AB. I want to prove that AB not equals MB, okay? And actually, that's wrong. That should be is congruent to MB. So what would my first step be? Given. Thank you, guys. Always go for the easy stuff. Line CM bisects AB. Given. If line CM bisects AB, what do I know about? And this is all wrong. I really messed up here. Prove that segment AM is congruent to MB. I apologize. My bad. How can I prove that, boys? Yes. Thank you. This is AM. AM is congruent to MB because if a line bisects a segment into two congruent segments, then they are congruent. So this is the definition of a segment bisector. Make sense? Thank you as always, guys. I hope you learned a lot and have a wonderful day.